And I see that we are almost bottoming out, but 145 amps and 1,300 volts. So lots of energy going into that motor right now. And it's increasing in speed rather quickly. The generator has a built-in oil pump that soon will be able to deliver enough oil pressure. And by that, we will have an alarm telling us that the oil pressure will be too high. So we are just below 300 RPM. Our target is 711.3. Amperage is going down. We're already down to 110 amps about. So when the motor is up to speed, 711.3 turns per minute, the generator will rotate with 2,115 turns per minute, or 35.25 turns a second. It's an incredible speed, but it's necessary for the generator to generate a radio wave that we need to transmit the message over to America. Ja. Här kom det. Nej, det är bara att stänga av. Det är perfekt. Oljan är varm. Next step, Jan-Åke, here. Next step is to wait until we come down to 80 amperage. And reason why we are waiting so long is that we don't want to shock this old machine. It's the only one in the world, and we don't want to break it. So now we have reached 80. Jan-Åke will start up two DC rectifiers, one for 500 volts and another one for 125 and 250 volts. And I will explain later what we are using those generators for. Now it's time to magnetize the 500 volt generator. That means that the transductors restricting the voltage will all of a sudden let all the energy through. So when you do that, Jan-Åke, we can see that the voltage here increases by 1,000 volts instantly. And the people here in the transmitter hall, you can hear and you can feel that the motor now has a lot more energy. And the speed is increasing even faster. We are at 550 RPMs. And now Jan-Åke will operate the start resistor. The start resistor is connected to the drive motor's rotor. And by lowering the resistance in the resistor, we gain a lot more torque in the motor. And the torque we need to get up to speed. And he will also operate the compensation resistor. The compensation resistor is connected to the drive motor rotor when the Morse key is pushed down. So this machine can only be transmitting Morse code, no speech or so. So Morse code is the only thing we can transmit. And I think it's time for Jan-Åke to magnetize the generator. Now we have an electrical flux, a changing magnetic field inside the generator. On the frequency counter, you can still see that the frequency is way too low because the speed of the drive motor is still not 711. So Jan-Åke, he will work on getting to the right frequency at key up of the Morse key. And we mainly do that by monitoring the voltage to the drive motor. We should be at 2,000 volts or slightly below that, that will be optimal. Lite tryck till, va? And now we can see that the meters here are starting to work. That means that a built-in speed control system is trying to take over. But we are still a bit too far away for it to work properly. So we have to help it to come to the correct point. And I think Jan-Åke is spot on. That's perfect. Now, next thing would be to turn on a large air blower, an air blower that will blow a lot of air onto contactors used for speed control, because the amount of power on those contactors is so great that they will instantly burn together without any cooling. And if you think that the noise now is loud, it will be a lot louder when we have the air cooling running in a couple of seconds. So we are still not out in the air. No one can hear us yet, but we are very soon coming to a point where all the listeners can hear us. And we have hundreds and hundreds and hundreds of listeners sitting all over the world, no matter what time of the day it is, to try to hear SAQ. So to many listeners, this is a great event, as great as it is for us to hear SAQ. Yeah. Now it's time for us to connect the transmitter to the antenna. And Jan-Åke will do that by operating a motor-driven night switch. Yep, and then that switch is engaged. And now we can test the Morse key if the machine is reacting. And now we are going out in the air. The amount of power to the antenna can be up to 200,000 watts, 200 kilowatts. However, this is an old lady. We don't want to stress anything unnecessarily. So the amount of power we are transmitting with today is about 80 kilowatts. And we'll see what power we have to the antenna. Oh. So. Jag tycker vi kör remsa. So now, when we have made some rough tuning of the transmitter, we would like to tell the world who we are. SAQ is the name of this transmitter. And we do that by sending the letter V, as in Victor, 3 times, V, 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 and then we send D, E, which means from in French, and then SAQ, over and over again. So now the world can hear that SAQ is in the air, we are transmitting. I will go and have a look on my where I can listen to myself. So I will see if we are getting through in Netherlands. Yep, it looks fine. You can see SAQ here. Den är ju inte jättehög. Nej. Ni kan inte se det, det kanske tar sig lite. Ja, ja, den är kanon. Ja. We see that the antenna current may not It's really nice and warm outside. As you can see, there are lots of people now eating ice cream, enjoying their visit to the radio station. It's a beautiful day, even though it's some small clouds right now, which makes the temperature really nice. Behind me you can see a cooling pond with some fountains spraying water. This cooling pond used to be a part of the SAQ cooling system when it was run 24 hours a day, 7 days a week. Nowadays we only run the machine for maximum 1 hour or slightly longer, but no longer than that, so there will be no time for the heat to build up that much. So it's no longer a part of the cooling system, but we like to display it like this, so it's a beautiful piece. And on my other side behind me you can see the massive antenna, also a design by Dr. Alexanderson. It's a so-called multiple antenna, which means that all the 6 towers together makes up one antenna. Each tower has an efficiency of about 2%, meaning that 98% of the energy arriving to the antenna will turn into heat. But 2% times 6 makes 12. So 100 years ago, this was an extraordinary achievement to reach as high as 12 or even 14%. The second best antenna was from Marconi. His efficiency was at 2%. And this antenna is also very narrow in its bandwidth. We have a plus minus 40 hertz bandwidth, and then we have plus minus 10% in accuracy or instability. So plus minus 50 in total, which is very narrow compared to the transmitters 100 years ago. The distance from the first tower to the last tower is 2.2 kilometers, almost a mile. And we used to make fun of this a little bit, that it's a rather small antenna, because for its wavelength, which is 17,440 meters, it's a really small antenna. It's not even an 8. A standard for an antenna would be a quarter of a wavelength. But Alexanderson, he solved that by introducing tunable coils at each down lead to kind of transform the antenna electrically into a quarter wave antenna. And further to the right, you can see one of the tuning coils that goes up to tower number 1. So by that, I think we go back in again. back in again. Är vi nöjda? Ja, ska du testa lite? Ja, då får du köra med den, hålla inne den. Nej. Ja, du får stänga av den. Ja, vi är nöjda. We are looking at the power and we realize that we are happy. It looks the same as yesterday, so let's not change anything that is working. So a transmission with SAQ over the antenna is a very rare occasion. We do this maximum 2 times a year. Sometimes not at all over a year. And to get out into the air, it's a lot of work, a lot of people involved to get all the technology working. Our listeners are all over the world. We have normally more than 500 replies to us from listeners telling us if they heard us or if they didn't hear us. Many times with images, drawings, video clips from when they received it. And it's a fantastic reward for us who have been working with all this to get all those confirmations back and with nice words and greetings. So we are a non-profit voluntary organization that we are responsible for keeping this machine in operational condition. And we do this with several people's efforts and money from all our members. We are about 800 members. Membership fee is roughly 10 euros, 12 euros. So anyone who would like to become a member should go to our website, alexander.n, as in November, .se, and apply for membership. And you are helping us to keep this fantastic machine alive. So I'm looking at the time, and we are still 5 minutes to the transmission, so that is good. Ja, tack. Anyone who would be interested in running this machine can take a training course here at the Grimeton radio station. We have weekend courses, and we want new people to come here. Women are extra welcome because there are not so many, but a few. But we want to have more people coming in to learn. I did that myself. I was brought here by my wife. I got this as a gift from my wife 15 years ago, and I fell in love. So now I have my wife and I have the radio station, and I'm very happy. So 100 years ago, when this machine was in operation, it was run for a month at a time, a whole month. It never stopped. And at that time, we had 2 machines here, not just one. Over on one side of the building here was the other machine located. So they were changing between the 2 machines every month. You can imagine working in this environment. It's a lot of noise. You were not allowed to wear any ear protectors because you should hear any strange noise if the machine needed to be fixed or serviced in any way. So many workers here, they lost their hearing really soon. And people who working here, they were often very young school boys. There were no women working here whatsoever. One woman paying out the salary, but for the rest it was just men. But young boys, 12 years of age, 13 years of age, they started their work here next to the generator. So now we have 2 minutes left. And now it's 1 minute left. And as the message now is transmitted to the world, you can actually see the characters that Very nice.